Okay, let's talk about electrical power. Um, in electricity, um, power, which is generally denoted as watts, named after James Watt, who did not invent the steam engine, he improved it to a point that it was usable. Power is equal to watts, which is equal to voltage times current. They use I for current and V for voltage. Voltage is the push in the wire, so it is the difference of potential between one side of a wire and another. You'll often see a schematic drawn as a ladder diagram. So here I have a switch, here I have a load, which happens to be a light in this case, and then it goes back to here. So voltage is the potential, how much push there is between this wire and this wire. That's what voltage is. Current is how many electrons flow from one side to the other. Electrons flow to try and equalize the potential between both sides. Okay, so a few other things you need to know. 1 horsepower at 100% efficiency, which there's no such thing, but 1 horsepower is equal to 745.7 watts. Okay, and then inversely, 1 watt is equal to 0.0, how many zeros? 2 zeros. 134 horsepower. Okay. Um, just as a side note, voltage is equal to current or amperage times resistance. So VIR. Notice how these two look very similar to each other. Okay, so here's power, here's voltage, horsepower, and watts is, and 1 watt equal to how many horsepower. Okay, so in a home, we have circuit interrupters. We generally call them breakers. Sometimes they're called fuses. A fuse and a breaker are different. A fuse is a piece of metal that will melt and become liquid, or become liquid enough that it drops away at a specific amperage. And a circuit breaker is a mechanical device that will open a switch uh, anytime current flows greater than its rating. Okay, general household circuit breakers are 15 and 20 amps. They also make, I don't know if they make a 10 amp breaker. I've never seen one, but I know they make a 30, a 40, a 50, a 60. So those are the amperages. Most receptacles that are in the wall, the plugs you plug into the wall, are 15 or 20. The 110 volts in the United States, it's 110 volts. Okay. So if I have a bunch of different things, let's say I've got a microwave, a 1000 watt microwave, and it is 110 volts. So this is my microwave. Okay. Let's say I've got a TV and it is pulling 2 amps. I'm sorry, it's a 200 watt TV. Still plugged into my house, so it's 110 volts. Um, oh, what else have we got? We can't forget our hair dryers. I have a hard time I have a hard time with the R's. So hair dryers are going to be quite a bit bigger. They're probably 1500 watts. And this is plugged into a different circuit, and I've got 115 volts on this circuit when I read it. You can have voltage variations inside the same house. Let's go ahead and just do some math here. So let's get our calculator up here, but first I want to find out what the amperage is for all of these. So using my wattage formula, I want to solve for I, so I'm going to divide both sides by V. That way those V's cancel, and I end up with current is equal to wattage divided by voltage. Okay. So let's go ahead and get the calculator up here. So 1000 divided by 110, that's going to be a 9 amp circuit. 9 point, I can't remember what it was. 9.1 amp. Okay, my TV, 200 watts divided by 110, that's 1.8. Okay, and then finally the hair dryer. That's 13.0. Okay, so would this fit on a 20 amp breaker? And the answer is no, probably not. I've got 14.8, so almost 15 amps just between these two. So, and generally what you'll see, not always, but a microwave will have its own dedicated circuit. If it's built in, they generally will put a microwave on its own. In your bathroom on new home builds, you have to have 2 separate plugs, and that is, the hairdryer is the reason for that. Curling irons also consume a lot of energy, so that also will do that. That is all I can think of for this, so there we are.